Mechanism of basic buffer solution. In this lesson, we are going to learn how a basic buffer solution retains its pH value constant even after adding a small amount of acid or base. So, let's go to the detail. Basic buffer solution. Let's consider a basic buffer solution of weak base ammonium hydroxide and its acidic salt ammonium chloride. Let's write. Basic buffer solution. Base is ammonium hydroxide and its acidic salt ammonium chloride. We know two equations. One is POH is equal to minus log of hydroxide ion concentration and pH plus POH is equal to 14. That means pH is equal to 14 minus POH. Suppose pH of this basic buffer solution is 9.2. In this solution, when small amount of strong acid or strong base is added to the solution, then pH value remains almost unaltered, unchanged. Let's see the mechanism. In the basic buffer solution, there are two components. One is ammonium hydroxide, another one is ammonium chloride, acidic salt of this weak base. Now let's see ionization of these two components. Ammonium hydroxide, which is a kind of weak base, that is why it ionizes to ammonium ion and hydroxide ion, that is only 5%. That means only 5% molecules ionize to ammonium ion and hydroxide ion because it's a kind of weak base. But ammonium chloride is a kind of salt that ionizes to ammonium ion and chloride ion. It ionizes 100%. The role of this salt in the basic buffer solution is it increases the concentration of ammonium ion in the solution. When in this solution small amounts of acid is added, then let's see how pH value remains constant. When acid is added, then it reacts with hydroxide ion to form water. So by this reaction, concentration of OH is supposed to decrease, and as a result POH value is supposed to increase, POH value, and ultimately pH value is supposed to decrease for the addition of acid. But pH value doesn't change because the amount of hydroxide ion that is consumed by acid which is added to the solution, that amount is filled up by unionized ammonium hydroxide in this way. ammonium hydroxide ionizes to ammonium ion and hydroxide ion. So the hydroxide ion that is produced from ammonium hydroxide, which fills the vacuum of hydroxide ion that is consumed by acid added to the solution. In this way, pH value remains constant even after adding small amount of strong acid in the basic solution. Here, according to La Chatelier's principle, some more amount of ammonium hydroxide ionizes to ammonium ion and hydroxide ion to fill up the emptiness of hydroxide ion. Now let's see what happens when small amount of base is added to the basic buffer solution. Addition of base to basic buffer solution. When base is added to basic buffer solution, then concentration of hydroxide ion is supposed to increase, and ultimately pOH value is supposed to decrease. That means basically pH value is supposed to increase for the addition of base to this basic solution, but pH value remains constant. Let's see the mechanism. When base is added to basic buffer solution, this base reacts with ammonium ion, and as a result ammonium hydroxide is formed. Ammonium hydroxide is a kind of weak base, so it doesn't ionize to ammonium ion and hydroxide ion. In this way, base added to basic buffer solution is consumed by ammonium ion, and ultimately pH value remains constant even after adding a small amount of base to basic buffer solution. In short, when acid is added to basic buffer solution, it reacts with hydroxide ion to form water. As a result, a vacuum of hydroxide ion is created that is filled up by unionized ammonium hydroxide, and ultimately pH value remains unchanged, unaltered. And when small amount of base is added to basic buffer solution, this hydroxide ion combines with ammonium ion and ammonium hydroxide is formed. Ammonium hydroxide is a kind of weak base. It doesn't ionize to ammonium ion and hydroxide ion appreciably. That is why concentration of hydroxide ion remains constant after the addition of small amount of acid or base. As a consequence, pH value of basic buffer solution remains unaltered or unchanged. This is all about mechanism of basic buffer solution. No more today. Thank you very much.